Alright, cool. Looks like we're live. Broadcom to acquire VMware in $61 billion deal. Interesting. Let's see. Let's see what the 10K is for VMware. I actually like VMware as a company. And I've seen it pop up a few times, but I just actually don't know what the financials are underneath. And I feel like this merger will actually go through, but I don't know. Let's see. I'm kind of curious. Before my client comes on, I want to do a quick look at the 10K. See if I can come with a quick valuation. Type and report. Okay, let's see. Quickly. Financial statements. I think they're gonna just put the cash flow on top. Oh, they put revenue on top. Revenue, license, subscription services. 10% year over year from their service, mostly driven by their services. Licenses are dead. Subscriptions are probably, yeah. Okay, subscription and services. It's because they turn everything to a subscription. Fuck that. I don't know. I hate that kind of business. But okay, so the operating income. Okay, operating income's pretty stagnant actually, but the revenues grow. So top line revenue is growing, but the cost of revenue is actually it's still kind of shit. Mostly because they're trying to market it. So okay, I see what's going on here. So let's just take these numbers at face value and assume that operating income kind of stays the same. Okay, so 419 per share. Net income. Holy shit, the net income is actually declining. Yikes. So their top line's growing, their bottom line kind of sucks ass. Current assets. Assets are growing. Assets are about the same. Ooh, there's a big goodwill. Bad here. Payable to Dell. Any deficit? Okay, retained deficit. Holy shit. Yeah, I don't know. This is really looking a little ugly to me. Okay, net income. Let's take the 2K at face value actually. Add back in. That's $3 billion. $24 billion. Yeah, even if you take everything at face value here, let's say you buy the 20 billion liabilities, you end up in the red here. $3 billion. Yeah. So like to me, I would only count the no, stock actually count. They're not buying back the stock, I don't think. So even if I gave them the $4 billion at face value, 32 billion, I would only pay like 32 billion for this company. I don't know. I don't quite see it unless they think that top line's gonna grow 10% year over year like that. Even then, I don't. And you apply to like it dropped, and you assume that it drops down to the bottom. You assume it grows at $1 billion addition per year. Yeah, okay, I see why they come up with the $61 billion valuation, but it's kind of a reach. You're assuming that top line revenue all falls down to the bottom line. I don't know. I think they're assuming this 2020 number keeps growing forever. Anyway, let's bring on my client. I don't see it. I think it's too much of a reach for me.
Hello.
Hey, what's up?
I'm good. Yeah, I can hear you.
Cool, I
Can
can
you
hear you too. Cool, perfect. Yeah, catch me up on your practice and how things have been. I know we talked last time about not doing stuff in your head and doing an example if it's clear to try and make things clear. How's that going?
I think it's going good. I've been trying to implement it. I do catch myself from time to time, doing stuff in my head, but it's more I test the examples in my head, rather than testing the code in my head. But so I narrowed it down, but that's still happening a little bit. Other than that, as for questions, I finished up to stacks, and now I'm about to do queues.
Okay.
Oh, I do have trouble with linked lists a little bit, just because of the pointer situation. But usually my high level description is good. Pseudocode is somewhat good, just doesn't account for some of those pointer mistakes that I do make.
Okay. So you're kind of like starting to get into the area where details kind of suck for you a little bit.
Yeah.
Other than that, do you find that your idea going into the code is bulletproof and fine?
Not bulletproof, but it's a lot better than when I started.
Yeah, I
Um,
kind of expected that.
yeah.
Okay. All right. Let me look at your practice diary then. I think it's a good sign if you're able to start translating ideas into code and it seems to work out okay. I remember at the very first session we had a big issue with that.
Yeah. I'm beginning a lot better of translating my ideas into code.
Yeah.
Yeah.
Okay, so yeah, I'm gonna say like every single coaching session we're mostly gonna spend at least 30 minutes trying to review your practice diary, and then the next hour and a half trying to do new stuff. Because what I find is that after talking to M and he got the Microsoft offer,
Yeah, congrats to him.
yeah, congrats to him. Is that a lot more benefit comes from making sure you're doing your practice right rather than going to doing new shit. So I think this time around I'm gonna try really hammering home your practices. So.
Okay, yeah.
Okay. Okay, so let's see. Give me one that you felt that you did good on, and give me one that you felt you did bad on. I think your entries look okay. Some of them look a little sus. Like I don't like for instance row 50, but you said you encountered
Uh,
multiple bugs on this one, so I'm kind of curious. What exact? Give me
uh,
one that you felt like you did good on. Let's start with there.
okay, so just any question I felt like I did good on. Um, so I felt like I did pretty good on the for for linked list ones. I felt I did pretty good for cyclicity. Um,
Wait,
cyclicity.
where the hell are your runtimes? What the fuck?
Oh yeah, I keep forgetting to write those. I thought I only had to do this for the practice diary. For the run times, I mean,
All of them. I'm gonna highlight them in red.
yeah.
So
I'll
now
start putting those in.
yeah. Okay.
Yeah, I mean, I test test for cyclicity should just be O of n, theta n. Anyways.
But you should still do this exercise. Okay, I'm highlighting in
Yeah.
red. Do not make me repeat that, dude.
Yeah. Okay. I'll put those in.
Okay. Anyway, so give me the one. Keep talking.
Yeah. So test for cyclicity, I think I did pretty good for that. As for like, cause I barely made any mistakes in testing the code out. Like I tested my code out and all that. As you can see in the error thought comment section.
Wait. Which row am I looking at?
Look, row 40. My bad.
Okay, pseudocode was not clean enough to find cycle length. Okay, let me pull up the original problem. This one is test for cyclicity.
Yeah.
Correct. Okay, just check to see if there's a cycle in the link list. Okay.
Yeah, and find the starting node of it.
Pseudocode is not clean enough to find cycle length. Lands are costing time to design. Design needs to be more clear. All right, let's take a look. So you said that you felt like you explained the idea better. Or what do you think the strong point is?
Huh?
What do you think the strong point is here?
The problem is, I think, I didn't implement the find cycle length method clear enough. For the pseudocode wise, at least.
I see. Okay, so let's take a look here. In terms of cycles existence, if a cycle exists, then find the length of the cycle. Well, the thing is that you have to find the thing is that the way you write your pseudocode is that you have to find that the cycle length exists. And it's okay. So this is a requirement of the problem, sure. And so you have two pointers cycle length apart. So that's the thing. The thing is that the problem seems to test. Hey, make sure you test for cyclicity. But in your problem statement, you actually have the reverse going on because because you're assuming that you can find the cycle, see if the cycle exists. Do you see what I'm saying?
Say that again.
So
last part.
The question is asking to see if a cycle exists in the linked list, right? But the way you've written the pseudocode is that you've assumed this as a predicate, which means that you have an easy way to find if a cycle exists, which means you've already solved the problem.
Yeah. Okay. Yeah. That's true.
It's a logical error. It's like the problem is asking you to find that cycle if a cycle exists, and then you're saying if that cycle exists as a precondition. But the thing is that, well, how do you figure out if a cycle exists? That's the logical thing here.
I mean, I did in my pseudocode somewhat like account for that. Is like while iterating, I did the fast and fast.next. So basically, if I do if there's no cycle or the fast and fast.next are not null, will reach the end and it'll just return and there's no cycle. It'll just return none or something.
Okay, I see. I'm gonna say that.
It's like that Zeno's paradox sort of thing. If
Yeah, you get
you know what
infinitely
that is.
close.
Yeah.
Yeah. So here's the thing. So the thing is that I'd be much more explicit because this is a logical fallacy right there. So I'd be much more explicit in how I describe the cycle. So I feel like in looking at this, you figure out the fast slow pointer, right? If there is a cycle. Okay. I think
Yeah.
really you kind of did this a little bit on the fly, and then find cycle length. Okay. So the question now becomes, how do you find the cycle length? And I don't see the pseudocode for that. Is it?
Yeah, that was the problem. I just wrote a high level description of it. When I put in find cycle length, so I think that did mess me up a little bit. I did encounter like a infinite loop at one point, but then it was just a like really easy fix. But I shouldn't have encountered the infinite loop in the first place.
Right. Again, think of someone walking into the middle of the room, reading your plan, and with no prior context, it should be easily understandable. So it's like, okay, how are you gonna find the cycle? That's the most immediate thing that stood out. And you, like you said, you screwed up because you couldn't define it. And to me, I was like, well, I don't see you defining it anywhere. So it's about recognizing, hey, wait a minute, this is not super obvious. Like if it's not super obvious, you probably need to define it.
Okay, yeah.
Okay, so let me write that down. Yeah, I'd rather at this point I'd rather you overdefine things and clear things up, and then rather than skip it, because you can always take things out later, but adding it later on is going to be much more painful.
Okay, yeah.
Other than that, let me see your code. Give me a second. Let me my glasses. And it's little fast pointers. Okay, yeah, sure. So the thing is that I'm familiar with this pattern, so I know what you're doing here.
Yeah.
So while fast and fast out next are not null. Move the slow pointer once, move the fast pointer twice. Yeah. I understand. Okay. No, it's fine. I think you wrote this. It's fine. So the thing is that, yeah, you're gonna run into you might run into. Oh wait, no, you won't run into an infinite loop. It could take very very long to find it, so it's fine. Yeah. So your problem is actually in the cycle length.
Yeah, it was implementing that because of my unclear pseudocode. I got a bit lazy when doing that. I thought it was pretty obvious, but then it turns out it wasn't really obvious, and then
yeah, I'm gonna tell you, like, if people screw up in a problem, it's almost always because of one mistake like this. Even M had the exact same problem in the last what's it called, coaching session we did. It's like, oh, you've got to do a few examples or some shit like that, and that blew up your ability to do the problem. And even then, he still did well, right? So the thing is that you want to avoid these as much as possible. Again, it's not like it's never the execution or the final result that is going to be the problem. It's almost always one step that led to a chain reaction here. So in this case, it's because you didn't define cycle length that led you to writing this code that led you to fucking up the cycle length. So other than that, like, again, like, it's readable. That's fine. It's just that you missed one detail.
Yeah.
But it's much better. I will say, yeah. So that's okay. So give me one that you felt like you did shit on.
One that did shit on. Let me find. No, that was okay.
Okay, give me one that you weren't able to solve.
Yeah, I think it was the implement to click right shift for a singly linked list. It was row 46.
Cool. Okay. So remember, that's hey, I have no idea what's going on. I should be able to read this and be able to understand what the fuck you're doing. So you couldn't solve. Got high level idea, but the pseudocode was hard to create. Okay. So you have 1, 2, 3, 4. K equals. Oh, okay. I see. Yeah. Perfect. Great. You described the example. So it's if K equals whatever, then you shift it. Okay.
Yeah.
All right. Describe the step. Okay, describe the steps and logical thinking that you went through to get this problem.
Okay, so basically, I tried out the examples at first. You know, K equals 1, K equals 2, K equals 3. I'm like, okay. It seems like the tail is moving to the front depending on the K amount, and then basically, that came to me. We don't need to shift K that many times. Like what happens if K is bigger than the length of the list? Then there's gonna be a lot of unneedless shifting. So first thought. So then my thought became, okay, let's just mod K by the length of the list. So we don't have to do as many shifts. After that, it's just the just the less than length of list shifts, right shifts, and then now the problem became, okay, how do I find the new head? And then I kept thinking, okay, we came from the tail. Like we moved the tail to the head in our cyclic right shift. So let me see if find the kth node from the last of the list helps. And then I kept trying to find a pattern for that, and I thought I did, but when I tested it again, it didn't really turn out too well.
Okay.
So yeah.
Okay. So let's. So I see what happened. Okay. So first things first. Good. You recognize. Hey, yeah. What happens if there's too many shifts? Okay. And then you put a band. I would say this is a little bit of a band-aid, but it's not in the sense that you kind of squared it away and thought, oh, I took care of the super long, super big K case. But I
Yeah.
would argue that this is also another hint, because if you think about it, it's like you said, like, oh yeah, I just need to keep shifting the last tail over to the front, right? I think this is like your line of thinking. But to
Yeah.
me, like when you do that, to me, it's like, well, wait a minute. This is so expensive. It's so difficult to, keep gluing the tail back to the front and keep repeating that exercise over and over again.
Yeah.
That would be like the red flag. If something seems excessively complex and unwieldy and just seems like it's just wasting time, it's a waste, and there's probably most likely a simpler way of doing things, that's probably where you want to attack.
Yeah. So essentially, my idea became I need to find the new head in the new node inside my linked list, but I was having trouble finding, like, creating a calculation to find the new node and the new head in the new tail of my linked list.
Okay, yeah. So you need to find the new head, the new tail, right?
Yeah.
And so the question then becomes, okay, so you iterate k times to get the new head, right? But the thing is that essentially because of what you got going here, you can just glue the tail to the head.
Yeah, glue the tail to the head. Yeah.
Because it's like if you shift, you're moving the tail anyway, and gluing it to the top. So that'd be my next thing. It's like, hey, wait a minute. No matter what I do, if k equals 1, I'm always gonna be gluing the tail. So why don't I just iterate through the list n number of times, break it off at that point, and then glue the tail to the head, and boom, I got my new list.
Yeah. I should have thought of that. It didn't come to me in the moment.
No, so this is where the heuristic of, hey, wait a minute, this looks fucking complicated. It's not as obvious to
Yeah.
me. It's not slapping me across the face. Let me see if there's something simple here. Sometimes it works, sometimes it doesn't. But it's just one heuristic you should have under the belt.
Okay, yeah.
So it kind of goes back. If not super obvious, you might need to define it. Or conversely, it's like the inverse of this. If it's super complicated and complex and unwieldy, it is probably wrong. Probably. The reason why is because it's a heuristic. Or at least you should try eliminating all the simple ones before you dive into it. Sometimes the complicated one is the right way to go, right? It's like, hey, wait a minute, this seems a little weird. Let me eliminate all the other simple possibilities.
Yeah, if like a simple solution exists, you should probably try that first, then rather than going through the complex ones.
And even if you didn't, like, say, like, this idea didn't come to you of gluing the end, right? You would just say, hey, like, you should just notice the pattern. Like, what am I doing each time? I'm breaking it off and putting it in front. Well, can I, instead of breaking it off and putting it in front multiple times, can I just do it one time?
Yeah.
So you should recognize. Let me type that up. Recognize if you're doing repeated work, you might be able to get away with only doing it once somehow. So this is where your inefficiency comes in, right?
Yeah.
So it's not just like runtime; it's also operations as well. Because technically, the operation of just breaking the link and then adding it's just memory shift. So relatively speaking, it's not just like it's not very complicated compared to all the other things you could be doing. But in the end, it's still an inefficiency because holy shit, I'm doing an operation of gluing and ungluing it multiple times.
Yeah, for sure. Yeah.
So.
Like, I think if I really wanted to, I could just like I could always just convert this to an array and do the array cyclic right shift thing.
Mm-hmm.
That would have probably been a brute force solution thing, but that would probably cost too much memory.
Yeah, but at least it's you solved the runtime issue, right? And then all
Yeah.
you do is just like take the runtime thing from that, solution, and then combine it with what you got here, and then boom, you should get a solution. So it's like there's many paths to Rome here. It's just being able to recognize like overly complex and fucked up solutions that are like not clear.
Yeah.
So other than that, like I think you're on the right path for sure. It's just that I think you could have described it a lot better.
Yeah.
Yeah. So I'm looking at
There are other entries in the diary where I implemented the approach proper. I implemented the naive approach, but I couldn't get the approach inefficiencies of my thing.
Okay, so show me one of those because I'm looking at Rose 47. This pseudocode just looks like code. I have no fucking idea what's going on here.
Okay, yeah, that was pretty bad. I mean, it was more like it was coming from the intuition of the high level, the high level description line. Row 47. Basically, you know, since they zero index the linked list, right? So even though it's always first, an odd number always comes after an even number, and even number always comes after an odd number. So essentially, I just alternated setting the next nodes of each linked list that I had. EPI did it a lot cleaner than I did, but we had like the similar idea.
Right, but the thing is that you have to ask yourself, why is their code cleaner? So you have to ask.
Yeah.
So what was the thing that made their code cleaner versus yours?
So I think I had it in my error comment thoughts. They basically use the turns variable to indicate if it's an even or odd node. So basically they had like a binary number 0 or 1 that indicated, okay, are we on evens turn or are we on odds turn now? So they reduced the lines of code and they made it a little bit cleaner.
Okay, I mean, I don't mind the 2-pointer approach that you got going here, but to me this is like it's not clear, and I think that's kind of like that's partially contributing to it as well. You look at the complexity, like if you're basically just writing code at this point, so I would consider this a bad sign.
Okay.
Notice how you just explained it to me. I think your explanation was a lot better than whatever the fuck this is.
Okay. Yeah.
Yeah. Remember, it's like I should be able to walk in, read this, not know what the fuck the problem is asking, and then be able to understand it just from the solution. It's a simple litmus test that you should do.
Okay.
Because remember, like, keep in mind, the interviewer has probably 10,000 things that he's fucking doing, and interviewing some random kid is probably the last thing on his mind, right? He doesn't give a fuck.
Yeah.
So it's like, okay, make it easy for him. Just say, make it easy to explain, make it easy for him to snap back into the conversation and understand what the fuck's going on.
Yeah, especially if they zone out or something too.
Yeah, believe me, that happens a lot. Because it's like,
yeah.
Because I'll give you a perfect example, like me. Like, I give so many fucking interviews, I'm just like, I know I just like zone out sometimes, and I come back in sometimes, and I'm just like, okay, wait, let me clarify what you're doing here. And it's because, sometimes the guy talking just kind of rambles, and I'm like, I have no idea what the fuck you're talking about. And so I kind of zone out. I'm really trying to help, I'm trying to make sure whether or not this guy is like good or not. But at some times it's just like it's a human tendency, right? And I'm gonna try honoring and being fair to him, but it's just like I'm saying for you to make it easy for him.
Yeah, for sure. Yeah. I totally get that.
Yeah. So this is what and plus it helps you clear your thoughts too. So there's no downside to making the idea simple beforehand.
Yeah.
Other than that, yeah, it's definitely better, but it could be better. I would say like yeah, especially from rows. I would say like the list pivot. Yeah, you need to do the pseudocode again. Go back over your practice diary. Look back at the things that don't look like pseudocode or simple explanations, and fucking redo that.
Yeah. Well, what was bad about the implement the list pivot thing? Row 49.
So row 49. Let's look at it. So 49. So int pointers as we traverse head, data of add less than x equal to x greater than x. Add it. What is it? Traverse head. Why do you need to have 3 pointers?
Oh yeah, I should have add head to. I should have replaced it with head.
Yeah, because think this way. Imagine like you went through a hard day, you turn off your brain. I was like, can you read this? What it's trying to do? I don't even know what the problem is asking. What the fuck's list pivoting?
Yeah. I should have put it in a high level description at first to make it a bit better.
That's because the reason why I'm making you do that is so you can explain, like I just said.
Yeah, okay.
That's what pseudocode. Because at this point, your bots will be writing the fucking code.
That's true. Yeah.
Give me the high level executive explanation.
Oh, right now? Okay.
No, I'm saying like in general.
Okay. I mean, for this question, yeah. Oh yeah. In general, yeah. Go.
Okay, yeah. So I'm gonna say the rest of them. I noticed like lines 50, 51, 52. You didn't really write anything other than like the delta.
Yeah, I mean, yeah. Basically, like it was pretty simple. That I just yeah. I mean, yeah. I got lazy because it's really simple on adding list-based integers because it's really similar to how you would do it for arrays, just with linked lists.
Okay, I see. Yeah, so so I'm gonna say right now when you do the code, let's when you do the entries. Okay, I'm gonna make this very explicit because I see you're getting lazy about this.
Yeah.
Pseudo.
I think it was for the later half of the latter half of the linked list. I got lazy, but then I picked it back up when I started doing stacks again. But then
Okay.
I do need to make my high level descriptions again.
All right.
Yeah.
Okay, I'm putting it in your sheet, highlighting in red every single. I don't want you to redo the practice diary entries like in this format. So now I've written it very explicitly. No excuses.
Okay. So you you. Okay. Yeah. Okay. That's the format I follow. Yeah. Okay.
Yeah, thought delta, and be a little bit more explicit on your thought delta. You have to really dive deep. Why? You need to get to that one aha moment.
Okay. So like thought delta, basically, what I've been doing right now is like, how what like I don't know, like basically how they made if our idea is the same, what code did they use compared to mine, sort of thing. When I put
Not just
like,
that. It's why.
yeah.
Why did they get that code versus why didn't you get that code?
Okay, yeah. I mean, I guess cleaner making their code being cleaner isn't good enough of an explanation. Then I guess.
Why is it cleaner than yours? And not to mention,
Yeah.
it's not just like why is it cleaner than yours. Why did they come up with that clean code? Are they doing like some like crazy ass Python syntax? In which case, I was like, okay, fine, whatever. But if it's like if it's so simple, compact, and easy to understand, why isn't yours? Even though you had the same idea. What was there like
Yeah.
another idea or organizing those ideas that they had that allowed them to come up with that clean code? Because remember, clean code comes from clean ideas. And like I said,
Yeah.
there's always one singular moment, one singular idea that will allow you to execute or go down that path. So it's not just saying what they did, but why they did it.
Okay. Yeah.
Different code solution than you. What thought did they have that allowed them to easily navigate to their solution? Okay, cool. So I think that if you look at I would say recommend look at the sample practice diary again.
Okay.
Yeah, I think towards the bottom. This is I'm giving you M's entry, by the way, so
Yeah.
you can see. Yeah, but I'm saying that you need to be able to do what he did. So like let's look at entry 228, right? Merge two sorted lists. I think you have something similar, right?
228. Okay, yeah, I see
first
it.
tab. Look at how meticulous it is.
Yeah. Okay.
I mean, he doesn't like write the pseudocode, but like he kind of does. Like trace the algorithm, testing plan. He is recording what he does. But at the end of the day, look at the last one. Compared to the book answer, I could have made my answer a little bit more cleaner, removing the two if-else statements just by checking if both nodes are true and not just as one. So that one little detail that would have cleaned up his code. In the end, just linking the remaining list would save the extra iterations in case we have a node, blah blah. So describing the case in which it would save him a bunch of other shit. So why did the idea exist?
Okay.
So
yeah.
Not just what it is, but why.
Okay, yeah. I think I did copy one of M's framework for one of the questions. I just kind of forgot which one it was.
You can
I think it was one of the later ones too, but I just don't remember which.
I would say look at the later ones. He gets a lot better at it. Look at also like how he nitpicks as well, like starting from like row 184 to like 185. Like he's saying, here's what he did good, here's what he did bad. Like even those nitpicks.
Nitpicks, yeah. Okay, yeah.
You see how like meticulous we can get with these? You do this up front, you will save yourself a lot of time later on.
Okay,
So do not get fucking lazy about this.
Okay.
It fucking pays off. Look, if you can get one shot, I'm going to remind you again. If we had one shot on Microsoft and we landed it, it's because of this shit.
Okay, yeah, I need to be more meticulous with my diary entries. Yeah. I don't know if I'll do the time ones, but I might do the... Should I do the time ones, or should I just go for the good, bad, in addition to my pseudocode and stuff?
Go for the good bad right now. We'll get to time later.
Okay,
I'd rather you be complete. Remember, during the sessions, I always made it a point to get to, hey, make sure you can solve the problem if I gave you an infinite amount of time. And then after that, we will get faster. You're probably not at that point yet.
Yeah.
So, remember, clean thoughts lead to clean code. Clean code leads to good answers. Good answers get you an offer.
Yeah, one chance, one shot.
Yeah, you got one shot, man. Don't fuck it up. Don't fuck around, man.
Yes, sir.
Yeah, I'd rather you be you'd rather be overly detailed. And then it's like, okay, then I can tell you, hey, this is not necessary. This is kind of wrong, and then we'll eliminate it. But at least you can keep track of all the things that went wrong.
Okay, yeah.
Hold up, yeah. So there's like I know like Kobe Bryant has a fucking like TV series of like called Details or something, and he's like Details win championships. There you go.
Okay.
Yeah, I recommend you watch that because I can't really play it because otherwise I'll get like copyright strike. There's like a chapter of him like basically reviewing tape.
Okay.
Of like, oh yeah, here's why the thing worked. Here's why we here's why we won. Here's why we lost. Here's what Scottie Pippen's doing. X Y Z. Blah blah blah. I recommend you watch that and you see how detailed he gets into basketball. And that's just like the surface level in order to try and appeal to a wider audience. Imagine like what he does for himself.
Oh yeah, it's probably a lot more complex. Yeah.
Yep. So in that case, let's move on to doing the problems. So I said I was going to give you a recursion problem. You said you were doing pretty well on it, so let's see if that's...
I mean, I got a lot more used to it. I'm not sure if I'm doing too well on it. I'm still a bit yucky, but I think I'm a little bit more cleaner with my thoughts for that.
Okay, let's see how far you've progressed. I mean, you said you blasted through it, so I'm assuming that you did, like, you're okay with it. If you're not, then you better go back and fucking do it over again.
Yeah, for sure. I mean, for the first few ones, I think I did okay. I'm not sure, like, I think I did okay, as long as I remember the steps that I did.
Okay, I'm gonna
like the logical steps, the insights and all that, not the actual code thing.
All right, yeah. So I know what problem to give you. Okay, let's go. This should be pretty simple. I'm gonna grade you mostly on the cleanness of thoughts and then the code. So.
Okay. I guess to the problem sheet or.
Yeah, I'm gonna give you the problem sheet actually. Let me restart the. Cool. All right, let's go. And stopwatch. Let's go. So, a set of positive integers. Find if it can be divided into two sets with equal sum.
Okay, so it's at the top. Okay, let me reload the page just really quickly. Okay. The problem is, given a set of positive integers, find if it can be divided into two subsets with equal sum. Okay. Yeah. Okay, let me start. So, let's generate an example first.
Good.
Of how to do this. Positive integers only. They'll be bounded by, the standard 32-bit thing, so I won't have to worry about that. Equal sum, automatically, that already gives me the intuition or, like, hint that this has to be even. If we cannot divide, because if you have an even, odd cannot be divided into two subsets. Odd sum cannot be divided into two subsets.
Why?
Because
you mean odd number or odd sum? Or what do you mean odd sum?
So basically you want to divide it into two subsets with equal sum, right? So two subsets with equal sum. That means that the total sum must be even, because that if you can't divide your total sum into two parts, then if you can't divide your total sum into two parts, then it means it's odd. It's an odd total sum, because if you divide odd by 2, if you divide an odd number by 2, so like 3 divided by 2, that's like a 1.5 or something situation. I don't really know.
Okay, I understand. Yeah. Yeah, they're all integers. Okay, that's fair for now. I understand where you're going with this. Sure.
Yeah.
But you still solved the core problem, so go ahead.
Yeah. You know. So yeah. Okay. You divided by 2. Yeah. So they have to be. The total sum has to be even. It can't be odd. So that's like a good base case check to have.
Sure.
Like your initial check. So maybe I'll write down initial check. Make sure sum of set is divisible by 2. Otherwise, we can't really do anything to it. But now let's actually go through an example of the problem to make sure to actually get an idea for how to solve this. So 1, 2, 3, 4, 5, 6. I know the algorithm. I know that formula for doing it, but I'm just gonna do it manually because, you know, I'm kind of bad.
Keep in mind, it's not, these integers might be random. They're not necessarily ordered.
They're not necessarily sorted? Yeah. I mean, that's fine,
Not sorted, they're not, like, incremental either. I could have, like, a million in there, you know?
Yeah. Yeah, it's just easier for me to count it up if it's, like, in sorted. So, yeah. So, 3 plus 3 plus... So, that's 6, 10, 15, 21. Okay, so that's 21. So, let me just get rid of the 2 to make this... No, wait. Get rid of the 1.
Okay.
There we go. And it'll be 20, and then we can actually do this. 5, 10. Yeah, okay, yeah. So we can actually now start solving the question. So how do we divide this into 2 subsets with equal sum? Let's just generate a subset with equal sum. Let's just generate it. Just generate 2 subsets with equal sum. So I think they both have to equal to 10 then, I guess. So 2... I mean, one of them is just 6, 4. And then the other one can be 2, 3, 5.
Okay.
And I think that's the only one possible. I don't think there can be other ones, because...
I don't think so either. So
yeah, I don't think there can be other ones, because that's the only way you can make a sum of 10 into each integer. Into each set. Okay, so let's try another one then. Just to be sure. Actually, just type out a random one. Let's do a random case now. 5, 10, 30, 20. Okay, so that's gonna be even because I'm 25. There we go. Okay, so 10. That's 30. 30 plus 40. That's 70. After that, let's try and divide it into equal subsets. So 5. So equal. Divide that by 2 is 35. So we have to put them both into 35. So
sure.
35. So 35. 25. 10. Okay, so I think my first idea is we divide the sum of the set by 2. So we get this number over here, 35. In this case, and in the first case, I'd get 10. And after that, it's just a simple case of checking if the numbers, like, it's basically, okay, we divide the sum by 2, and we check if a subset of the set can be added up to equal the sum divided by 2. So in this case, it would be find subset of integers that will equal 35. And up here is for 10. Okay, so let me see how I can put a tiny high level. Let me write down the high level description for it, and then we can start talking about the pseudocode and how we actually start implementing that idea. So get sum of set, divide set by 2. If set if set divided by 2 is even, then it is able to it's fine if it can be divided into 2 subsets with equal sum. So do I just return true or false for that, you mean, then? Or
What do you mean? It's just
it says,
it's a simple true or false, right?
yeah, so could it? No. Okay, no, yeah, you're right. Okay. I was thinking at first, hey, why don't we just can we just stop here then? If it's divisible by 2, then couldn't we stop here?
You could, yeah.
But I think we still have to. We should probably check if the numbers we can actually equal to that sum divided by 2.
Okay.
So just in case, if set divided by 2 is even, then it's able, and then a subset of the set may equal. If a subset then may equal set divided by 2, meaning a set of integers can be divided into 2 subsets. We only need to find one because the other one is just the numbers that didn't include the current set we have.
Okay, so you're assuming that if you have an even number, that there must exist a set. That's not can you think of an example of when that is not the case?
I mean, we're only doing positive integers,
yes.
So I think that should be okay.
Can you think of an example where that is false?
Okay, let me try and think of. So maybe just 60-10. Also 35 here. Yeah, and then we can't divide it into equal subsets of 35 there. So yeah. Yeah, so yeah, that's why I put it. And may equal. So we do specifically have to go check into our set to make sure it is equal to that sum divided by 2. Okay, yeah, that's a good check, yeah. Instead of just assuming that if it's divisible by 2, we can automatically return true. Okay, so yeah. So if set sum divided by 2 is even, then a subset may equal set sum divided by 2, meaning set of integers can be divided into 2 subsets.
Okay, so how are you gonna solve the problem? You're 10 minutes in, by the way.
Okay. I mean, this situation is that more or less what I'm thinking is just get all the possible sums of our array, essentially.
Okay, sure.
So we either when we traverse through this, it'll basically either take this number or really don't take this number, and we just go through the entire list doing that recursively, and hopefully we will find a true case for one of those, or a false case if it's not realistic.
I don't understand what the heck you're talking about.
Okay, so yeah, so traverse through our set. At each element in our set, either consider the current element for the subset with sum equaling set sum divided by 2. I'm just gonna put it like that to make it a bit easier.
Okay, at each element or second set. Okay.
Either consider or do not consider the current element for the subset. So essentially it's either take the current element or don't take the current element.
Sure. You could have just said that. Why do you need all these words just to say that?
I guess. That's true. I should probably simplify it a bit more. I thought it'd be like being a little bit more descriptive would have been.
Yeah, but break it up if you're gonna do that.
Okay,
Like again, remember, walk into a room. Does someone want to fucking read what the fuck this means?
Mm-hmm.
So make the language simple.
Okay, yeah. At each element in our set, either take it or don't take it. For our subset, that'll probably be a bit cleaner for that. Let me just add a little comment thing there to make sure I don't confuse myself. I mean, I think that's the high level description, essentially. Sure. After that is just return whether we were able to make a subset equaling set sum divided by 2.
Okay. So what do you? Okay.
Pseudocode now.
Well, you came up with a pseudocode here, so you.
Oh, okay. I mean, yeah, I guess that works too. My pseudocode usually.
That, yeah, I need the high level description should be like an English sentence and basically be the pseudocode.
Okay.
That's what
okay.
The entire time. Did you think that just writing code and pseudocode were just the same?
No, more like my pseudocode would be a little bit more descriptive than this. Like it would include like the null checks and all that in the base case checks.
No, you might write
but
code
not
at
exactly.
That point.
Huh?
You might as well write code at that point.
Yeah. Okay. Then I guess this makes it a bit better then. Okay. So yeah, I guess it's time to make the code then. So I guess I'll just define it as a function. Set positive integers. So subset can be divided into 2 subsets with equal sum. This is a really shitty function name, but
it's fine.
Yeah, okay. Taking a set. First of all, if sum, I know Python has this. I'm not sure. I think Java has this too.
It's fine. If you just use whatever Python language library you got going.
Yeah. All right. So yeah, if sum of set, divisible by 2 equals to 0. I know there's a bit way to do this, but it's not that. I still have to think about it a little bit before writing it, but this is a simple way and a lot more people understand it, so I'll just write this instead. Return false. Oh wait, no. Not equal. My bad. Got confused there. So yeah, if set, I'll just actually put this onto a new page so it'll be a little bit easier to read. So, yeah, that return false. After that, I'll need to make a helper method for to actually implement this.
Okay.
So let me do this. Def helper. If in an actual interview or something, I'd probably just copy paste the name and then add a help.
You could do that because you're gonna be doing the problem virtually anyway, so it's fine.
Okay. Yeah. Helper. Okay. So yeah. Take the current index because that's how I'll be iterating through it. And what do I do for? Yeah, I need to take in the set too. So yeah. Actually, instead of index, I'll put current. So that'll probably be a little bit more descriptive instead of saying index, like current index we're on. So yeah. Okay. So yeah. Now we traverse through a set. At each element, either take it or don't take it. So basically, let's get the index first, a length of set, because we need to know when to stop traversing. So if current equals n, then return whatever. So what's the case when it's equal to 2? Let's return false, because in the base case, if our set is empty and you know, if our set is empty, we can't really divide it into two. So that's kind of a false there.
Okay.
And now, you know, oh yeah, I should probably pass in. No, I don't need the sum. I can set it since it's a closure sort of thing. I can just say set sum equal sum set divided by 2. So yeah, divided by 2. My bad. Yeah, and then basically sum over here. If sum is equivalent to set sum, return true, because
Okay.
you know we reached our set sum.
Sure.
We're good. After that is now we either take each element or don't take it. So now it's just essentially just calling this method again. Sorry. Ugh. Yeah. I'll assume it's in the, okay. There we go. Cur plus 1. You know, set sum plus sum plus the current number. So set cur, essentially.
Okay.
Well,
okay. Where does this +1 come from?
Cur index right over here.
Oh,
Cur is the index. So
well,
I'll initialize it with 0 first. Let me just call it.
Why is it called cur? You literally just said it's an index.
Yeah, I named it index previously. I thought cur would be a little bit more descriptive since that's like the current element we're on, like current index we're on. Or should I probably type it out?
Okay, let's pause. Imagine a 5-year-old walks into a room and asks them what cur is, and you say it's an index. Then
okay.
What do you think the response is?
Why did you name it index?
Wow, it's almost like asking, like, if a 5-year-old walks in the room and looks at the problem, it solves the full fucking problem.
Yeah. Okay, yeah. I
didn't do anything fancy here.
Yeah, you're right. Yeah.
Of course I'm right.
Okay. And then now, essentially, it's just don't take the element. And that's the don't take the element part. So.
Okay. So you could call this now what?
Yeah. Now, assign these to assign these results to something, to a variable, and basically now we return whether we were able to make it, like if we were able to make the set sum with one of these subsets. So just basically return subset 1 or subset 2, so it can rebound, or like it crosses over into every single level of the recursion.
Okay, sure, fine.
So that's why the or is there instead of and only if we need it at every level, but we'll need it at one level, so that's why the or is there.
Okay, fine. All right, I see what you're doing. So some. All right, so then, are you done?
Let me just call the function first, because if we don't call the function, then it's never gonna be ran. Okay. So return that. 0 first, pass in the set, and 0, and that should be it.
Okay, let me ask something. Okay, is that it, or do you?
Yeah, that should be it. Yeah.
Okay, do you have any bugs?
Any bugs? Let me change this back to index. So there shouldn't be any syntax errors now. We are always going through the same set. We're not changing the set, but we're still passing in the set.
Okay.
Okay. Over here also needs to be index, because now we're adding it. I mean, another way instead of adding is I could pass in the set sum over here and just minus it. In when it equals 0, we return true, but I think this is also the equivalent part of it.
Okay.
But yeah, I think we know for sure this line will make it terminate, because we're only we're traversing by one element each way. So it'll eventually return something.
Okay.
So there's no infinite loops. This, it doesn't have to return every time. It only needs to return one of the times if it's true. So that's okay. That won't progress us towards termination. That won't determine whether we terminate or not. So I think it's okay.
Okay.
This one.
All right. What's the time space complexity on this?
2 to the n, because we basically create a set for every single level of recursion. So at each level of recursion, we create 2 recursive calls. So essentially that's 2 to the power n. 2 to n. 2 to the power to n, yeah. Let me just write it down so I don't
Okay,
there.
All right.
N where n is the length of our list set.
That's fine. Let me stop there. It's fine. So I'm gonna ask you what you think you did right, what you think you did wrong here.
Okay. Let's start with what I did wrong then. What I did wrong, probably I shouldn't have gotten confused when typing out the high level description a little bit. I feel like, because I was a bit confused, like, oh, this settles for pseudocode sort of thing, and then I should have made my pseudocode not my high level description thing a little bit more descriptive, so I wouldn't take as much time coding as I did. So that would probably have been a little bit faster.
Okay. Do you remember what I told you on how to evaluate your performance or like your mistakes or anything? Do you remember what I said?
ELI5, like, what happens if a 5-year-old works in the room? What are they gonna say when they look at your code? Can they follow you?
Mm-hmm. Yeah. So let's go from top down, and I want you to put your 5-year-old hat on and see if you can follow it.
Okay. Yeah.
Yeah. I'll do a quick check and let me know if you notice some things.
Okay.
And think back to your performance as well, like what you did, what you said, and all that stuff.
Yeah. I feel like this. Okay. First of all, this check would probably be a little bit simpler. Could a lot be summarized into maybe a few more succinct points. That was a little bit me struggling to explain the concept. I think I skipped a few steps in the beginning, explaining the concept, so you did get confused a little bit. Probably write out more steps. So 2 steps with equal sum equals total sum must be even. But I think this line sums it up pretty well then.
Okay.
The line.
Fine.
Odd sum cannot be divided into 2 subsets.
Sure.
Yeah. I should probably write only even sums can be divided into 2 subsets.
Mm-hmm.
Because just to make it so the interview doesn't have to think that as much as they want to, sort of thing. And just like save them some time. Just in case it's not clear.
Okay.
Initial check, make sure sum is I think that's okay.
Okay.
Sum of set is divisible by 2.
Okay. Yeah, I'm gonna tell you this part's fine. Let's get your pseudocode.
Yeah.
Anything here you feel like is kind of messy?
Probably I should have. I know you said like not to use variables, but I found like not using variables was a bit difficult to describe set sum divided by 2. I think there'll probably be a bit better
this
way.
Is fine. The reason why I say to avoid using variables is because I don't want you to write code. If this is the only way to simply convey the meaning, that's fine. I'm okay with sum divided by 2.
Okay.
All right. But other than that, do you think there's anything else in here that's wrong, or you think it's okay?
I think it'd be okay. Maybe I should have specified traverse through a set. Maybe specify that as left to right. To make it a little bit clearer. I know there's better words instead of traverse through our set.
Okay.
But I just cannot come up with it at the moment.
Okay.
I know I wasted time saying this instead when I could just say this. So that was kind of a waste of time. Okay. I could have explained it better off the bat. Mm-hmm. I should always evaluate each line if a 5-year-old walked in, like at any point in time. So
remember, it's a 5-year-old with fucking ADD. They don't have time to read some rambling.
Yeah. So this, while I was typing this, they would have probably got very confused with what I was trying to do. So I think if I just settled with this, it could have been a lot simpler.
Yeah.
And then I think this is okay. Maybe make it a bit more descriptive though. Maybe check like return if one of the subsets we created have a sum equaling set sum divided by 2, then return true or return false.
Okay, that's fine. Other than that, okay. So let me stop being around the bush because I think you're not you're hitting around it, but you're not hitting the target. So let me show you my notes. And
yeah, for sure.
You might understand something. So first things first. You basically spent the first 5-7 minutes talking about, oh yeah, like if it's not divisible by 2, then we don't care about it, you know. And to me, that's a red flag because, well, how does that help you solve the problem? It just it just makes your problem more efficient. Because let's say I took that out, right? Let's say I took out the divide by 2 or whatever fuck it was. Like, in fact, I don't even see it here. Oh yeah, I see it here, right? Let's say I took this out.
Yeah.
Your problem could still be solved without it.
Yeah, essentially, yeah.
So this is just an optimization on top of the core idea. In other words, this doesn't really help you solve the problem. And you spent 7 minutes on it. Why?
Yeah. I mean, when I was going through the problem, I thought initially, let's rule out half the cases we need to test.
That's fine, but why did you spend 7 minutes doing that?
Yeah, I mean, I guess I kept thinking my explanation was poor, so I kept on re-explaining it, and then it just ended up wasting time on that shit.
Yeah, so the core issue is your explanation just kind of suck ass.
Yeah.
So this is where, like, being meticulous in your practice diary of, like, the pseudocode and all that is going to help you.
Yeah.
So you kind of see, like, where you being, like, lazy about the practice diary and your practice is biting. So.
Yeah.
So you waste 7 minutes on there, which out of the 20 minutes, that's literally a third of the time based on some random shit you don't need to do.
Yeah. Okay.
I'm just gonna make the big one. Be efficient with your words. We had this problem with M, but he got over it pretty well. It's like you're wasting your time on it. Maybe equal. Does it help you advance the problem? And it's plainly obvious. Yeah, to me, I would say anyone walking in the room. Oh yeah, if it can't be divided by 2, then we can't get an answer. Okay, that's fine. Anyways, but then it's like, how do we get the answer to begin with? I don't need you to spend 7 minutes trying to re-explain this very simple idea.
Okay.
It's like, yeah, even at 10 minutes, all right, you're not even closer to solving the problem. All you said was whether the sum is even or not. So it's an incredible amount of time wasted. That's basically it. And so after that, please use simple language. Your pseudocode should be English sentences. It's again, the reason why a pseudocode exists is so that way you can explain it to a 5-year-old.
Yeah.
So if you have to start writing English sentences that is basically code at that point, it defeats the purpose.
Okay, yeah.
And I think you mentioned that you got confused on it. I'm like, well, look back at our past sessions. When did I ever write something that was so specific about code? I think the only time was like the 3 loops, but that's only because I had to describe loops.
Okay.
So.
Yeah. Okay. So that little high-level description thing should be a little bit more clear enough that it can be taken as pseudocode. Okay.
Correct. Next thing. I would say, like, there's a few other things here. Your naming convention kind of sucks. You could have just wrote helper, and I think we would have understood that. Index, same thing. Well, what does this represent? Oh, it's the index. So why you not name an index?
Yeah.
Simple. Other than that, and then I would say you kind of threw out the plan again. It's the same mistake. I felt it took you like basically 6 to 10 minutes, 6 to 8 minutes to finagle with the code. To me, it's just like, well, your pseudocode you have a plan here, right?
Yeah, I think I did stick to my plan though a little bit. It's just having the variables a little bit off in the beginning.
Okay, let's do this. Let's do an exercise here.
Okay.
I'm gonna copy your plan. I'm going to paste it to where it corresponds to your lines, right? And for the sake of argument, let's do this. So divide the set by 2, right? If the set.
Yeah.
So where you divide the set by 2? Okay, so this is the your sum check here, right?
Yeah.
Okay. If the sum is divided by 2, blah blah blah, can be divided. Yeah. So this is it. Why is the idea so much longer than the code itself?
Yeah.
Next thing. Traverse through our set, right? So it's so the thing is that's kind of like where you have a little bit of issue, but it's gonna be a little bit more. I'll tell you where I'm going with this once you'll see it. At each element, take our set or don't, right? So this just means that at each point, take our set or don't.
Yeah.
Right. And then return whether or not we're able to make subset calling. Do you notice something?
My if cases were totally unaccounted for in high-level descriptions.
Yep.
Yeah.
So no wonder you're complaining. Oh, I got so confused. And it's the same thing I mentioned.
Yeah.
Where is it in your plan? It's like
Yeah, I probably should have mentioned that because I thought I think I thought the traverse through our set was sufficient for the first one at least.
okay, that's fine. Yeah, sure. And you got that one pretty much off the bat. And then you said, oh, you struggle with this one.
Yeah, that one is because I should have put that in the pseudocode. That one was a mix of shitty name conventions and forgetting to set the parameter sort of thing. Yeah.
Another thing. If I took this code out, would your code still be able to run?
Oh no, not really.
Really? Yeah. Exactly.
I mean, it would run, but it won't get you the right answer because there's no case for when you were returned true.
So which means I would say that's pretty critical, and if it's pretty critical, you might want to add it to the plan.
Yeah, that's true. Yeah.
So there you go. I mean, it's technically part of this, but it just means that if you didn't catch it, that means that the description kind of sucks ass. So that's why if you look at any of the pseudocode I've written in like this session, like in previous sessions, it's always very simple. Like I very rarely go over one line, in fact.
Okay, yeah.
So it's like I want you to do exactly the same. And so again, like notice how like the lack of planning, or at this case, like missing just some critical elements really throws you off.
Yeah.
And it's also the fact that you just get overcomplicated here. So again, the fact that you don't like really grill yourself on the pseudocode and setup, it blows up in your face here.
I feel like my naming conventions, I try to reason through my naming conventions, which caused me a bit of headache later on because, my first thought when setting the parameter was index, and my first thought was for setting the function, it was also helper. But then I tried to reason through it, and then I just came up with these long-ass stupid name conventions.
I mean, even if you always stuck with cur, you could just say cur index.
Yeah.
It's almost always the simplest and most plainly obvious is the right answer. And then you can always modify it later. Because it's easier to go from simple idea to complex idea, but not the other way around.
Yeah.
So it's like if you feel like, oh, you start with index and say, oh, wait, maybe I should separate index from cur index. Like, okay, that's fine. You at least you started off on the right foot, and then if something changed, then it's whatever. But the point is that I would say you kind of overthought it and just kept trying to be way more descriptive than you needed to, in which case you kind of went back and it's like a loop, right? There is a middle ground where you have just enough explanation to help someone understand, but you don't overly explain it either.
Yeah, okay, yeah.
And this is where like you being really a harsh critic of like your pseudocode and setup is going to help you, is that if you can come up with very clean ideas, then the naming convention will easily follow. So the overall takeaway I want you to take away from this is that, yeah, you kind of get recursion, I get it, and you were able to execute and get the code. It's just that your setup kind of sucked ass, which is why, and you focused on the wrong things that didn't help you solve the problem. That wasted. Yeah. You could have easily gotten this down to like 12 minutes.
Okay, yeah. The first 10 minutes was kind of iffy on explaining nonsense stuff that I could have just set off the bat, and it would have been easy enough to understand.
Right, so whenever you say something, you always need to focus on how does this get me closer to solving the problem.
Okay, yeah.
So let me write that. And then also, since you abandoned your plan, if you have a bug, look at the plan. Did I say that you abandoned your plan? I'm pretty sure I did.
Yeah. Well, I did keep to it mostly. It's just that one critical line, which is really not helpful. But I guess I got closer to it, I guess.
Sometimes not executed on the plan. I mean, that's fine.
Yeah.
All right, so you have a plan, commit to it. Did I write that down? Plan it. If you planned it, commit it. Yeah, so this is the inverse of that. Fine. Okay, I didn't explicitly write that, so I'll be forgiven. So it's like if it's critical, probably write it in the plan and stick to your plan unless you absolutely run into a problem you didn't foresee.
Yeah.
Okay. I mean, I'm writing a lot here, but it's really important that you make sure that you're doing everything that I wrote here. I mean, I don't expect you to do everything because there's like only so many things you can focus on, right? So. But
okay, yeah. I mean, I'll try my best to do every single one.
Right, but I expect you to at least be very meticulous and detailed in your diary entry, and really, really be harsh on your own mistakes.
Okay, yeah.
No, don't fuck around. We have only like 4 weeks.
Yeah.
So, okay. Now we'll do one more question, but at this time I want you to focus on basically just trying to keep everything we talked about today right now in your head, and really execute on it. Make sure that you're super, super careful about your pseudocode.
Okay, yeah. So clear a pseudocode and don't ramble on for too much. Keep it simple, the explanations.
Mm-hmm.
Okay.
Okay, let's see. I think I gave you the lowest common ancestor problem before, so... Yeah, I gave you the lowest common ancestor already, so... Nope.
Yeah.
That one's too easy. Root to leave with a specified sum. Perfect. Okay. This should be a fun one. So fine, I'm not gonna time you on this, but I want you to do everything we talked about, especially keeping your plan bulletproof. Make your plan bulletproof, if you remember anything today. So find a root to leave with a specified sum. So what we're doing with this, let me copy paste the sample output. So, for instance,
wow, this is really cool.
Yeah.
The output, like the pasting. I mean.
Yeah, because I have this problem on a sheet already. So.
Wow.
Okay.
Yeah. Okay. Yeah.
So for instance, this path, you can find a path to leaf here with a specified sum of 10 to 28. I fucked up here because this should be a leaf. So, and I can also find 10, 13, 15 as well. Does this make sense?
Yeah. Okay. So we found two paths. They both equal 38 because 10 plus 13 plus 15 equals 28. And I mean 38, and so does 10 plus 28. Okay. Yeah. And we only need to find one path or all paths, because the question says find a root to leaf with specified sum, but in the output it's basically outputting all paths.
Good catch. Let's just say for now, let's do all.
Okay.
Yeah, you're right. You caught that. So yeah, let's do all.
Okay. All right. So let me just find. Let me just all paths that are root to leaf with specified sum. Okay, so try the description first. I mean, try the examples first to see what I'm getting at. So, you know, what I think. Okay, no, I shouldn't rely on other problems first, like, because I was gonna reference
solve it logically. Solve it step by step. If you skip
yeah,
steps, I'm like,
solve it step by step.
Give me the logic.
Okay. All paths are root to leaf with specified sum. So we need to essentially traverse either from bottom up or top down. I feel like top down would be a little bit better. Let me write that down. Top down approach of traversing tree would be a bit simpler because we can do sum minus root dot val. Yeah. So yeah, we can do that. So that a top-down approach would probably be a little bit simpler because of that. So you know, we check the current one, and then we have the current value. We have the roots, and then binary trees. It's only left or right. So then we make a recursion call to the left subtree.
Okay.
And minus the sum with the current roots value. Do the same thing with the right subtree. And when we do encounter the specified sum is equal to 0 and we identify it's a leaf node, then we can append the current path to it.
Okay, wait, hold up. You said when you get to a leaf node and the sum is 0.
Yeah. Okay. Then we can append the path we have traversed so far to our master list that will contain all our paths.
Okay, so does that mean that you're doing the subtraction and then evaluation in the same node?
What do you mean by that? So we subtract it. Yeah, we would do the check, the leaf check and the sum minus root dot val check in the same line of code essentially.
Okay, that's what I was asking. All right.
Okay, so yeah, so now let's explain it a little bit. So let's probably create master lists that will contain all paths, root to leaf paths. Be a little bit more descriptive for that. So yeah, so yeah, create a master list that will contain all the root to leaf paths. So
Okay.
I think so. Since we're doing a top-down approach, pre-order traversal essentially. Just in case the 5-year-old somehow knows. We're still gonna go through it, but pre-order just to get you a framework into what we're gonna do. So pre-order traversal essentially. So
Okay.
basically,
Well, assume that I don't know what pre-order traversal. Give me simple.
yeah. So pre-order traversal is basically we visit the tree and node, then right subtree, then visit the right subtree.
Sure.
Yeah. But that's just like the typical, like that's just a skeleton sort of thing.
Fine.
Yeah. So basically, you know, while we're traversing through our tree, we check if current node is null, right? If check if it is null. How do I do this? I shouldn't say check. Basically, just if not, yeah. So if current null, then you know return return if some return null return null. Yeah. Now you know we do need to specify. This is where we check for the leaf. So now we check for the leaf and sum equals 0. So we do this by let me just actually implement it so we don't get confused later on when implementing code. So now we check. So it's a leaf when it doesn't have a left child and a right child. So if node has no children, then and sum minus node dot val equals 0, just return copy of path.
Okay.
Yeah, so return copy of path. After that, we traverse our left and right subtrees essentially. So recurse on left subtree, recurse on right subtree, with sum minus node dot val.
Okay.
With sum minus node dot val.
Okay.
So this
well, keep in mind you tabbed it, so it looks like it's underneath the condition of left.
Oh yeah, my bad. How do I untab this?
Just backspace. There you go.
Space. Okay, so yeah. So yeah, that's how we're gonna go for this.
Okay.
But this does not really specify how we're adding to the list currently. We have a return a copy of the path, but we should probably specify how we actually create the path in the...
Well, not just that. You said you're returning it, but then you have a master list at the top. So what the heck's going on here?
Yeah, okay. Let me specify this.
Yeah, define... remember, recursion. Define what you put in, define what you're going to get out.
Yeah,
you skip
that step. Tree... Technically, this doesn't really return anything, because we're only appending to the master node.
Okay,
the master list.
That's fine.
Yeah, but I'll just specify like a post condition sort of thing, like what's supposed to happen when the function is done completing.
Okay, so this is going to be a helper function or something?
Yeah, helper function, yeah.
Okay, you need to notice, like, why did you just say that this is a helper function?
That's true, yeah. Helper function, post condition, all paths will be appended to all valid paths. Will be appended to master.
Oh, by the way, question. I don't think post condition is a very common saying. So, is that common nowadays amongst you kids? Is that
I don't know. In school, they usually say post condition. I can just say.
I mean, school says it, then fine. I mean, to be fair, it's if that's what you're used to and it makes sense, and if you're asked what's post condition is, then you could translate it to what I'm working with is helper function. Then okay, if school calls it, then I understand. But to me. I never adopted the language of academia, so I guess I'm kind of stupid there. So okay, fine. If that's common for you, fine. As long, but again,
I mean, I wouldn't say it's common, but it's just something I use. I know my language is a little quirky and rambling.
Yeah, don't worry. We'll discuss that later. But as long as it makes sense and you can translate it simply to other people, then that's fine.
Yeah. Okay. Yeah. So, all valid paths will be appended to master list. Yeah, now we have to figure out. So now we just got the basic check of if this current path is with specified sum. So basically, probably just input a path variable, path transition there.
So what exactly is path? What type of variable?
I mean, a path is just gonna be path will contain our node values, because I see in our output is just 1028. We don't have to return the node of it, and if we do return the node, that's gonna be a bit weird too, because essentially we're just gonna be appending the tree multiple times.
So what type of data structure is this? Let me just simplify.
It's an array.
Okay, no, we could just say it's an array of node values.
Oh yeah. Okay.
Yeah, you overcomplicate it.
Yeah.
Just like as an exercise, I should make you describe everything in 10 words or less. Let's do that. And next time, if I give you another problem, I'm gonna put that limiter on you, and let's see how well you do.
Okay.
Wait, I need the fucking. Damn, I need a soundboard so I can do the face slap or something like every single time you fuck up. I didn't invest in a soundboard, guys. So I'll take all the money that I got from M and then invest in a soundboard so I can I can do that sound.
Oh my god.
Okay. All right. Anyway, enough joking around. Let's get back to the problem.
Okay. So yeah, array node values. So let's not go for the optimization off the bat. I know, because if I do the both at the same time, it'll mess me up. So, recurse on left subtree. So left subtree already include, and then path plus node.val.
Okay.
Same thing here, path plus node.val.
Sure.
Because we include it. Then remove last value of path.
Okay.
No. Yeah. I mean, this is gonna be a little bit iffy. Remove node.val from path. That probably simplifies it better.
I mean, I used to say pop last value. It's fine.
Yeah, I mean, I didn't write that because I specifically didn't append it. I just did the plus notation here.
I mean, it's kind of understood that's append, so it's fine. You could just say either way, it's fine. I don't think there's any harm in doing that. Pop the last one. It doesn't matter at that point because it's kind of implicit. So don't worry about it.
All right. Then yeah, all right.
Okay, so did you try testing this code yet, or I recommend? Okay, one point to point out is that in the future it would really help if you tested out the code, or at least ran through it on a high level just to make sure it worked in your head.
Yeah,
or not even in your head, just explain it. You did that, right? So the question now is, it seems like it works. My question is, what have you've tested for the happy case? What are some weird cases that your code might want to account for?
Basically, if you're giving us an empty node, like an empty tree, essentially, you didn't give us shit.
Sure.
So that's the if current node is null, then return null.
Sure.
Case,
What else?
because
What other situations might you want to be able to test for?
I mean, I can't say there's no leaves, only one node.
Okay.
But then, that's all. A node by itself is just, still a root to leaf path, because there's a root and a leaf at the same time.
Okay.
So technically, I think we do check that over here. If node has no children and sum minus node.val equals 0,
fine.
Return the copy of the path. Okay, I did find a bug here. We probably have to append code plus path plus node.val here.
Okay.
Because, if it is our node, then we have to include the current node too, because we do the sum minus node.val here.
Mm-hmm.
So we do have to include that current one.
Sure.
I think other than that, I can't think of any more test cases off the top of my head.
That's fine. Okay, so the reason why I bring that up is that even though your code's right, I would have also thought, okay, so you thought of all the different compositions of the tree, that's fine. But then you also have the second part of it, which is the value, in which case you might want to consider in the future, what if I ran into a negative number?
Oh yeah.
So keep in mind, you have two dimensions here, right? Is the tree and then the values that it can take on. Remember what I talked about for cases?
Proof by cases?
Proof by cases? Yeah, that tells you with the tree, right? But then there's
Yeah.
a range of values that you need to be able to handle, which if for the integers themselves. In which case, the most easiest, obvious one is can you handle zeros, can you handle positive numbers, and can you handle negative numbers? If you can handle all those and any mix of them, then you are golden.
Okay, yeah.
So
I mean, I think positive and negative numbers will also account for this because the negative over here would just essentially just turn to a positive.
Yeah.
So it'd also be 0, and it still has to be a leaf too, regardless of whether it's positive or negative.
Okay.
So I think that check still works out.
Okay, that's fine. Yeah, like I said, it's just something to think about. And one more thing, I want you to not return the values, but the nodes themselves. So.
Okay. I mean, it's just a simple, just remove the no dot val part from it.
Yeah, that's fine.
The dot val part, yeah.
Yeah.
You want me to like code
Yeah,
it
go.
up?
Yeah. Just knock that out of the plan and then code it up.
All right, so yeah, let's just create res over here. Just basic thing, array node values. Help. Help. Let's define the actual function first. Root to leaf paths. Find root to leaf paths. Give us a root and a sum. I know in Python sum is an actual keyword, but you know, not really caring at this point for it. Def helper. Okay, treat. Sorry, I'm just coughing a lot. Path.
Okay.
That should be specified inside the function. I'll specify it after. Over here.
Okay, remember you have a plan up there. Why don't you follow the plan?
Yeah.
Okay, fine.
Yeah. Okay, reversal. Sorry. If root equal null, I know it's none in Python, but you know,
That's
just
fine. It's whatever.
Be more agnostic. No one really cares.
Doesn't matter.
Return null. After that, now we check for so if root dot left equal none, and root dot right equal none, and sum minus root dot val equals 0. Where is it? Res dot append. List of path plus node. So yeah, that does that. Let me just put it to a new line. I mean new page because it's getting confusing looking at it. After that is recurse on the left subtree. So helper root dot left path plus node. Same thing over here. Root dot right path plus node. And now we just do path dot pop from it. But let's make it so it's a bit more. There we go. Move some extra lines of code that we have and make sure that the path.pop actually works.
Yeah.
And I think that should be it after I actually just call the functions. So helper and return res.
Okay. Alright.
So yeah.
And yeah, it's time. Guess how long it took you to write that code?
3 minutes, 5 minutes.
3.
Yay. I mean, that was pretty quick then, yeah.
See how it's just simply going through this, making sure we got everything? I mean, there's more things we could clean up. Also, keep in mind that you return null, but you specified that your function wouldn't do shit. Also, keep in mind you may want to eject after doing this.
I mean, I can just return. Yeah, that's true, yeah.
Yeah, few things to fix, but overall, it's pretty much the right thing. But yeah, overall, notice like how much like time we spent hammering away on the idea, and then it just like code was like 3 minutes, easy, super easy to write.
Yeah.
So, in other words, you get a lot more bang for your buck by trying to focus on this shit.
Yeah. What happened? Like I remember like when I was previously let me simplify it. When I was previously doing interviews before, I remember sometimes the interviews like you're spending a lot of time designing this code, and then that sometimes freaks me out a little bit.
Yeah.
What do you suggest I do? Sort of thing, just fasten it up. Then I tend to skip corners when they tell me to hurry up.
The reason why they're telling you to hurry up on the design is because you're probably repeating yourself and talking about pointless shit.
Yeah, probably. Yeah.
Your design isn't advancing the discussion. So it's like if you like spend all your time, it's like remember that whole thing at the beginning where you're spending 8 minutes talking about like sum divided by 2. It's not core, it's not core to the fucking problem. It doesn't advance the discussion. Why the fuck are you spending 8 minutes on this shit? But if the conversation for design is just like trying to test every single possible corner case, trying to evolve the idea and make sure it's okay, everyone understands. But what you're doing just basically is you rambling, and I think if you watch this coaching session again, you will hear yourself ramble. In fact, I highly recommend once the stream is over, listen to yourself and just like realize how agonizing it is.
Yeah, I probably need to do that.
Yeah, I mean, like literally watch it over and over and over again, and just burn that in your head.
10 words or less.
Yeah, if I'm gonna make you do the 10 words or less exercise, it's gonna be very God. I need the soundboard, guys. I need the fucking soundboard. You know, maybe I can like. Or some shit. Can you hear that?
I can't hear anything.
Fuck. It's like me trying to slap my hand and trying to do like the face slap sound. So I need to fucking do that. You know what? I'm gonna order on like this weekend. I'm gonna order a soundboard on Amazon just so I can fucking turn that on.
Jeez.
All right. Okay. One more problem, but you're getting the idea, right? You're hopefully it's like yeah. This is the payoff. This is how important it is to keep the idea clean and sticking to the idea.
Okay. Yeah.
Cool. And I don't want you to be like super frivolous with your practice diary either. So.
Okay. Yeah.
Okay. One more problem.
I'll follow like the format that you gave out.
Yeah. And also like review the problem sheet that we're doing here. So let's see.
Yeah.
I already gave you this one. Let's see. I don't want to give you a recursion problem. I want to give you something else.
Oh thank God.
I mean, I already went through recursion. I think you need to like kind of clean up your recursion thoughts again. We'll do another one next week, but I want you to at least make sure that you have the thoughts clean on that.
Yeah.
Oh wait, no. This one's easy. This is too easy. Nope. Nope. This is hard. Too hard for you. Shit. Okay, let me. I have to pull up the other problem sheet. God. Like, some of these problems are just like too hard for you. So okay.
If they are too hard, do you mind like just sending them to me later so I can try them on my own?
We'll do them later. We'll do them later when you're ready.
Okay.
I mean, some of them are like relatively difficult, but you know, I'm pretty sure M can handle it.
Yeah.
Let's see. Oh, Zigzag Traversal? Maybe. Hold up. Let me get the problem statement for this one. Yeah. Cool. Let's do this one. Okay. So, get a binary tree. Let me insert a page break here.
Okay, yeah.
Okay, I got. All right. Given a binary tree, return the zigzag order level traversal of its node's value from left to right, right to left, left to right, alternating in between. So, for instance, this is I've given a 3, 9, 20, 15, 7, blah blah blah. You get the idea. So the zigzag order's traversal would be from left to right, reading 3, and then right to left 29, and then left to right 15, 7. Excuse me. Okay. So.
Okay.
How do you want to do this?
So, I'm guessing our first traversal will be left to right, right? Because 3, since it's a single node, it's hard to tell.
I'm sorry. If I'm slow, it's because I'm counting the number of words you're using. So.
Okay.
If I see a sense you're going too far, I'm just gonna say redo it. So keep going.
Okay. So, question is first level, left to right.
Okay.
Okay, I'm just gonna assume it's left to right then.
Yeah. Start off left to right, and then yeah.
Okay, yeah. Start left to right. I'm also kind of counting myself too.
Don't
the
don't.
first
I
level.
will slap you if it. I can't really fucking slap you through the internet, but. God, I want the soundboard. Fuck. Alright, I'll tell you. I'll tell you when you're fucking up. So okay, just keep going.
So first level, start left to right. Second level, right to left. This is a binary thing. Either left to right or right to left. There's no other choice.
Well, binary. What the heck does that mean?
Only two choices. Only two.
Well, yeah, no shit. Of course, you can only go left to right or right to left. Of course, that's very fucking obvious.
Yeah. Right to left. This is done by level order. This is done based on levels. So, standard traversal, breadth search, which is also known as level order traversal.
I don't care if it's level order traversal.
Yeah.
Just progress through the problem. I don't give a shit about like this fancy ass terminology. I'm a 5-year-old fucking kid.
Yeah. Okay. First left, start left to right. Traverse all nodes on level according to proper level traversal.
The fuck does that proper traverse? What the fuck's this?
Yeah, I'm not sure. Like proper, like according to Zigzag. Or according to Zigzag level. No, that's not true. Traverse all nodes on level according to Zigzag. Zigzag order. Okay, you know what? I'm just gonna scratch that.
Yeah, start out. Yeah, you're not explaining this right.
Yeah.
I get what zigzag order is. Don't get me wrong, but I'm like, come on, man. There has to be. You gotta come up with an easier explanation for this fucking shit.
Alternate between left to right and right to left when traversing level by level through our tree.
Okay, fine.
Yeah, okay. I mean, only two choices of traversal, left to right. Yeah, alternate between left and right, left. Well, okay, no. This isn't exactly just. This is gonna mess me up if I continue with this. So, when traversing the level by level through our tree, indicate if our order should be left to right or right to left. If right, traverse all nodes on level left to right. If zigzag, if level should be right to left, then just reverse the added nodes.
Okay, let's stop for a second.
Yeah.
So, what might be an easier way to express what you've just written? Do you think a 5-year-old is going to read all this and understand it?
No, I mean, it's a little bit too much for a 5-year-old. But yeah, let me see how I can make this. I'm
going to give you 30 seconds on this and then I'll tell you what's the other thing.
So, I can just say, when traversing level by level, make every other one, reverse every other level.
The fuck does that mean?
Okay. When traversing our tree level by level, add all the nodes left to right. Every other level, reverse the added nodes.
Sure.
The reverse order of the added nodes.
Okay, you know, why don't I make this easier for you? If on an even level, go left to right. If on an odd level, go right to left or some shit.
Yeah. Okay.
Or have a flag.
Yeah.
I think that was less than 10 words, right? Or some or maybe around 10 words. I don't know. But my point here is that if you just keep it simple, right? It's like you don't need to over-explain it. Just say, hey, I'm going to use this component, and this component means this. Now it's like you have a flag saying what. You just said you had a flag, right? That's like a proxy for whatever the fuck you're doing, right? Flag have a flag indicating left to right or right to left, and then flag is true for even rows, flag is false for odd rows.
Yeah.
Or something like that. You know, you're gonna need to be more specific. But notice here, notice
Yeah.
this one advances your discussion. It's like, okay, now I have a variable that I can use to determine what my traversal is. This does not. This is just way too descriptive.
Okay. Okay.
Okay, so now that
I'm just like sometimes I get a little bit. I'm afraid they might get a little bit lost when I'm like not being descriptive enough.
well, okay, let's put it this way. I'm lost because I don't know what the fuck to focus on here.
Okay.
Like, okay, put your 5-year-old hat on. Compare the top one to the bottom one. Which one is a lot more clear to understand?
The top one. Have a flag indicating left to right. Yeah.
Okay, and I'll tell you this: in 90% of the cases, if you write things simple, you will not lose the interviewer. Interviewer will just say, "Hey, go faster." They're like, "Okay, fine."
Yeah.
Bottom case, if the interviewer reads this, I was like, "I have no idea what the fuck you're doing," and I'm gonna stay silent and you just do whatever the fuck you want. Which one would you rather? Which situation would you rather be in?
The one that quickens me a little bit. No. What were the situations again?
The first situation is the interviewer tells you to go faster. The second one is the interviewer is completely lost and does nothing.
Go faster.
Yeah, it's like, okay, now I can start skipping steps because the interviewer is like, he's saying like, go faster. Fine. I'll start skipping a few steps, and if he gets lost, I can always go back and be a little bit more detailed and simple about it. And because like, oh, I skipped some steps because you told me to go faster. It's like, okay, well, I guess we'll slow it down a bit. Second one is like, I have no idea how to help you.
Okay, fair enough. Okay, I need to be a bit faster, a little less descriptive, more ELI 5.
More efficient with your words.
Yeah.
That's what you need to think. How can I be as efficient with my words as possible? All right, keep going.
Yeah. Okay, so, for even, if odd, then reverse, added node. Return zigzag. Return. Oh no. Okay, yeah. Added nodes to master list. Return master list. Essentially, I think this is it for
Okay.
thing. Yeah. The implementation details is just.
But yeah, that's the thing. When I look at this, it's like, okay, well, how do you get right to left and left to right? Because the reason why is because 9 and 20 are not connected. They're not connected at all, right? So how the fuck do we access that?
Yeah. Okay. So let me explain. Like, put the level order traversal in ELI 5. When we encounter a node, check if it has children. It has children. If it has children, add those to a queue. Should I say queue or should I just say array?
Yeah, sure. Because effectively what you're describing is BFS, right?
Yeah.
So, okay, we'll discuss later, but yeah, keep going.
If it has children, add those to a queue. Yeah. When we encounter a node, check. So, what do we say? Init queue with root node. When we count traverse, while our queue is not empty, traverse through our queue.
Mm-hmm.
When we encounter a node, check if it has children. If it has children, add those to a queue. Add those to a level array. Init a level array.
What the fuck's a level? Okay.
I mean, array. The level array is just an array that will contain all the nodes at that level.
Okay, sure.
Yeah. You know.
Fine.
If set flag to not flag, essentially. init the queue to init the flag to even true first hand. If flag is false, reverse level array.
Mm-hmm.
Reverse order of level array.
Okay.
Add level array to master list.
Okay.
Return master list.
Sure. Okay.
And that's basically it.
Okay.
For...
I think your idea is right. The one concern I have is that whenever you come up with this, it seems like it kind of comes out of nowhere, and you don't really like come up with a example, like going through an example, and then kind of being able to test it and seeing where the idea comes from. I get that you're kind of patching it as you go, but it's a little bit concerning because it like let's take a standard interviewer, right? Let's take a good candidate. A good candidate would probably be like, okay, let me try an idea out, and then eventually you can kind of see where the idea forms because they tried messing around with some examples, and then they were able to step by step through it. So let's say oh yeah, I recognize that I just need to do BFS, but if I traverse a second level or every other level, instead of me adding elements to, let's say, the queue, I'll add elements to the queue, but then I maintain another array to plug in the answers into a master list. So I would come up with 3, and then I'll try iterating through 9 and 20. But since I need that to be reversed, I'll just have a secondary structure to copy that into. Something like that. So you kind of see, like, with the progression idea, like, oh yeah, I start off with the BFS, but this one, it kind of fucks up, right? What you did was basically you kind of just ended up saying, oh yeah, Q, it needs to be added here, I need to have a flag here. But there wasn't really a cohesive top-level structure that gave me guidance. In fact, you see like how it kind of ended up looking like a patch and pray sort of deal.
Okay.
It's like, I need some top-level guidance and some confidence in knowing that what you're doing is right. You know, don't get me wrong. The fact that you have a plan here is fine, and I get that it came out to looking like looking like actual code, but I think that's more a consequence of you patching and praying. Whereas when we did the other problem, right? Notice like how we basically kept it to simple English language, even though there's like kind of some code in there. It was a lot more Englishy and a lot more ELI 5 compared to what we have going on now. Yeah. Do you understand like where the reason why like some of your diary entries end up looking like code? I think it's mostly because of this.
Because I saw, because I probably do the pattern. Like it looks like I'm doing patch and pray.
Yeah, it looks like it, even though you might not be. But I want some top level guidance. I want like for you to test your idea before you actually go ahead and write that shit.
Okay.
So let me write that in your doc.
Yeah. I'm guessing so. When I do my hello description, I guess this isn't good enough for top level guidance. I guess. Probably. Like what you said earlier, you know, it's like a standard for search traversal. We would need a queue, add the children to the queue, and then we would have an array to store all the nodes on that level. Like describe it write all that down first, and then go through that.
That's part of it. Sometimes there can be a negotiation between it, right? Sometimes I might have an initial idea, I want to talk it out, and I think it sounds right based on me like walking through it. So for instance, what I just did here, right? It's like, oh yeah, this looks like BFS, except for every other level I need to traverse it. I need to reverse it, right? And so I would do like some structure, like I would probably just type it out, like, oh yeah, since I said all that, let me test it out. So my Q would equal to like 3, and then I would traverse and add, master list or some level list. And say, hey, yeah, now I'm gonna evict from Q, and then put 3 in the list, right? And then commit that level list over to the master list or something, right? And then I will put all the children into the queue again. And then I need to, it's like now that I do that, so, I need to blank out my level list. In which case, now like, hey, you say you init it, right?
Yeah.
Well, you're initializing over and over again. Why not just clear it out? So, because that might be a little bit more,
isn't it? Huh? Isn't that the same thing?
Well, if I create a new, you're basically asking what's the difference between doing list.clear versus list equals list. You're basically asking what this is, right?
I mean, yeah, essentially.
What is it not obvious? Like if I have list equals new list, and then I do list.add 5 da 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 da. Is this? Do you know what the difference is?
I mean, essentially, we're still using the same memory. We'll be using a new memory space with the ladder approach, same memory with the former approach, I guess.
Well, clear actually just like underneath the hood. I don't know how it works like in Python, but in Java, at least like it orphans it. It just basically makes all the removes all the references, makes them all null, so we're not like pointing to like integers, and then it just will clear it up. Versus this one, we're allocating a new block of array. So it depends on like what size the list is to begin with and what we're allocating, and being able to and requesting that new array. So what do I mean by this? So let's say like if I do list.clear, and this I know I'm going on tangent, but this is kind of important because you need to actually understand what goes on underneath the hood. Let's say my list is size of 25 initially.
Yeah.
And I don't fill it up. Let's say I do like add 12 elements. Well, I still have this 25 block of array, right? But then let's say I go here, right? 25, add 12 elements, and then add 12 elements, and then I clear it. Well, now I have this new thing here, 25 initially, and I've orphaned this. So in other words, I'm using more memory here before garbage collection.
Yeah. Okay, yeah.
So all this means is like, oh yeah, now these 12 elements will be cleaned up, right? But in the interim, for this one, I'm using an additional 25 elements before garbage, and I'm triggering garbage collection. So this one actually uses more memory, but it's being able to appreciate that difference.
Okay, yeah.
You say it doesn't matter, but I tell you, like, some interviewer is going to have a bad day, and he's going to nitpick you for that. But you saw what I did here, right? All I did was just walk through what all my possible variables are going to be, and I don't have, like, a flag right or left. In which case, like, oh yeah, now that I said there's a flag, I'm just gonna do flag equals false and some shit, you know? It'd be trying to negotiate, like, just walk through roughly what my variable's gonna be and whether or not it works. This is what I refer to as, like, stack tracing for recursion, but being able to, like, walk through it with the variables is a pretty good tool to test the idea.
Yeah, I do that sometimes in my diary entry, too.
You should do it more often. Well, not even just in your diary entry, but also just, like, in your actual practice.
Okay. So this is a question. So, would you say that this and like this over here, the testing the idea, and the high level description, do you think that suffices for like describing my idea and all that and like straight to code after this? If I just did all this instead of just writing out this lovely pseudocode that almost looks like code thing?
Yeah. The reason why is because once you have this idea down and you've tested it and you've tested it under all possible conditions, then the idea is going to be so much easier to write, and once you have the idea easy to write, then you can write the code.
Yeah.
You're still thinking very much, I think, in code to try and write the idea. I'm trying to get you to reverse. Think of it in terms of English, high-level shit, and then from that spawns the code.
Yeah, okay.
I want you to be able to at least run. This will also help because it helps you run through the idea. And, you know, of course, like, no idea is perfect the first time around. There's some negotiation you're going to need to do. But at the very least, by testing it in the real world with, like, some fucking variables, you're going to be able to at least come up with a better idea and a clearer solution to begin with.
Okay, yeah.
All right. So we have 10 minutes left. I want to be able to, I think you don't need me to go over this, but basically, bottom line, be much more detailed in your practice diary entries and make sure that I definitely recommend you rewatch this session because there's a lot of things we talked about, a lot of small things, a lot of bigger things. But the bottom line is I want you to be much more meticulous and detailed in your practice diary.
Yeah, and be a lot more clear with my words.
Correct.
Use less, be more succinct.
Yeah, exactly. If you ramble the fuck on, like, just try to catch yourself. If not, I think, like, even recording yourself and then listening back, like, this, you know, the same way we do for the replay analysis, doing that shit, and then just playing it back to yourself, you'll realize how much you talk. Like, I mean, I had that problem too, and then I was like, oh my god, I'm fucking interrupting people, and I'm going off on tangents, I better try and slow the fuck down or some shit.
Yeah.
Yeah, how you're gonna do that is kind of up to you. I can't really, I'm not a linguistics expert, I can only make you aware of the problem.
Yeah, I'll try, I'll figure out a different way to be a little bit more succinct in my language.
Yep. Anyway, so let's go to your practice diary on schedule. So your homework is to redo the practice diary entries, and I think that'll take you a while. And then to keep progressing what we mentioned the last week. List, linked list, stack, queue, array, string, whatever. Does that sound good?
Okay, so redo all my practice diary entries, or?
The ones that are shit, basically.
Okay.
And you also do not miss the runtime.
Yeah, I mean, I can write down the runtime. I can look at the pseudocode again, see if I get the runtime right from that. And then compare it to the book.
Yeah, exactly. And you need also to do the same exercise. If you get it wrong, ask yourself what the fuck went wrong.
Yeah. Okay, yeah.
Alright, that's the homework. I think it's pretty clear what we've done here today. You have your homework here. Maybe to review a little bit of recursion as well. It wouldn't hurt. Yeah. Go to the entire practice diary entries.
Yeah. Okay. So for homework, I already finished linked list. I finished the stacks. I'm on the Q section. So
Okay.
then I have a reason strings, just in case. I think that'll occupy me until like our next session for sure.
Yeah. So so you have plenty to do. I don't think I need to worry about assigning additional homework. We'll talk a little bit more about dynamic programming later on, but for now, I really would need you to get this down.
Okay. Yeah, for sure. I did notice that a little bit in the subset one. We could try DP for that, but I'm not too sure.
Yeah, I'm not letting you go on a DP until you at least master your ability to correct yourself.
Yeah. Okay. Yeah.
So. Yeah, plus, like, once I tell you exact, I mentioned this in previous streams, but the switch for dynamic programming is very easy.
Okay. I mean, yeah, somewhat.
Like, the same way I explained recursion to you and you instantly got it, just pretend I'm going to wave a magic wand and do that for dynamic programming.
Okay, yeah.
So, but yeah, you don't have much time. Like, you sent me, like, a message saying you have, like, 30 days or some shit. Don't fuck around with the diary.
Interview is June 27th, June 28th, sort of thing.
So don't fuck around with the practice diary. Don't fuck around with like that. So, okay. You get the message. You get it. Any other questions before I let you go?
I think that's it. Pseudocode, write the code, thought delta, be a bit more meticulous by doing the good, bad, nitpicky, and the thought delta.
Yep.
And don't do a patch and pray. Try and do the high level description first, along with testing of the plan.
Oh, you're gonna be okay, bro?
Yeah, I mean, I think I caught COVID. I'm not really.
Fuck. All right. Well, the good news is that 100% of my clients who got COVID got 100% on their offers. So
let's hope.
All right.
Yeah.
Okay. Seems like you got the message. I'll let you go.
All right.
All right. Talk to you later, man.
All right. Talk to you later. Cheers.
All right, cool. Let's see what you guys are saying. Are the numbers contain duplicates? I mean, I guess they can. But I think he solved it despite that. So, reduce a subset or two and find a midpoint. Yeah, there's plenty of ways to do that problem. The problem that Mr. Mystics is asking about is the divide a set into two subsets. And yeah, there's many different ways to approach it. You can do it like sort the array and then do 2 pointers. That also works, but it blocks you into n log n time. There's also a dynamic programming version of this, and then usually and this is a problem I used to give, but turns out I made too many people cry and fail with it, so I don't give the problem anymore. So basically, I would expand it out like, okay, well, what happens if we have 1 million numbers in the set? What happens if we want to create multiple sets that have a limit of X to it? It's basically like a derivative of the matchmaking algorithm that you might see in Dota or League of Legends. And that's how I would basically test people at the Senior Plus level. Although I think that most companies would consider that a little bit harsh. But I personally don't think so. Anyway, so 2-pointer data. Why is he saying method instead of function? It's not Java. It's whatever. Method, function, it's pretty interchangeable, I think. King of Rambling, yeah, we addressed that. Tree nodes have negative values, addressed. Soundboard would be hilarious. Yes, okay. So I'm going to order this shit on Amazon, and hopefully by, like, Tuesday when I stream again, I can have that soundboard set up, and I can have all the fucking sound effects in. So if you guys have any ideas, please send that to me, and I'll add them. BFS with a flag easily solves this question. Yep. This channel is hella underrated. Some gold content. I'm subbing and liking this. Thanks, man. I appreciate the love. 100% on offers. I need to catch COVID. Yeah. So Russell was the last guy before M that I coached. He went from 1 year of experience working as a contractor at Facebook to getting offers from Uber, Google, and Amazon that broke the levels.fyi bans. I think for level, if I remember right, the number was that he got $250,000 from Google. Yeah, that's about right. And Google underpays like fuck. I think the standard offer is like $180,000 to $200,000. And he had COVID before the Uber interview, and you know what? He still got an offer. So you know what? The point I make is that if you're complaining about how unfair the interview is or it's shit, keep in mind some guy got COVID and did an interview and passed it. So I mean, to be fair, that statistic is biased towards a sample size of 1, but I like pulling that fucking joke because it's funny. I get to, like, slap people around on that. It's like, hey, 100% of my clients who had COVID passed interviews. What can I say? So, it's a fucking joke, but I think my track record speaks for itself. I guess that's everybody. It's getting kind of late. So, I even know it's 11:30, but I'm not a gamer anymore. I haven't played a lot in a while, so I can't stay up late that much. But thank you all for joining me. We will have a replay analysis stream next Tuesday, so I'll see y'all then. I think probably around 8 p.m. And we will have M back on, hopefully to chat a little bit about his Microsoft offer. In case you didn't know, he was able to actually lock that down, and we're gonna go after Amazon as well. So we'll be able to chat a little bit about that, but we'll do a full analysis later. But for now, we're gonna be looking still at the practices and hopefully evaluating them. Jay will come on as well, and we will see how far he's progressed. So thank you all for joining me. If you guys like this content, please like and subscribe. Follow me on my socials. Links are in the description down below. And if you guys need coaching, you can book me for interview coaching at eachhandtech.com or career consultation. But until then, I'll see y'all later. Have a good night.